So the first thing we want to do is isolate the x squared in the x term. So actually I take it back. The first thing I want to do is distribute through the parentheses. You'll notice that some of these examples, they're maybe not exactly the same. I think one is exactly the same, but similar to the examples we had in the last section because they're quadratic again. So first thing I'm going to do is get rid of the parentheses. Okay, so we want to isolate the x squared in the x term, and with an equation, this is exactly how I do it. Instead of leaving the 5 with the x squared in the x term, I move the 5 to the other side. I luck out here because it's already been done for me. The second thing I'm supposed to do is make sure my leading coefficient is 1, and I actually luck out. This one's an easy one that I'm trying to start us with. The leading coefficient is already 1, so I don't have to do anything. What I would do if there was a number there, though, is not just factor it out, but actually fully divide it out, divide both sides by that. Since I now have an equal sign, I have more tricks that I can use than just adding 0 and multiplying by 1. So now is the complete the square step, finally. Finally, we haven't really done anything else. You take your b, you cut it in half, you square it, and we're going to say that gives us x squared minus 3x plus 9/4. And now, instead of having to also subtract the 9/4, we just add it to the other side as well. So now we're maintaining balance by keeping the two sides the same instead of just by adding and subtracting to make sure we didn't actually change the value. So let's see, what does this give us? This is 20 over 4. So I have 29 over 4, and I do try and do a little simplification as I go so it's easier at the end. And I'm on what was my step 4, which is factor the perfect square. So remember, I guess in some ways I gave us kind of a tricky one because this is a fraction. This number right here should always come into play. We want to split the factors are supposed to be identical. So when we do that inside outside, they have to be the exact same number, which is always going to be half of whatever this is. So minus 1.5 squared. And I would say if you're continuing to just not really feel like you get what's happening there, multiply it out, x minus 3 halves times x minus 3 halves. If you do that enough, you'll start to see why this works, why we need half of that number, and why this is the square of that number. That's my best advice. I can say different things, but I think it won't help unless you just kind of play around with multiplying those out and see why those match up. So we're now done with the steps we would have done for expressions. Again, they look a little bit different because we have the equal sign, so we can move some of the mess to the other side of the equal sign. But what I want you to notice is the whole trouble with quadratic equations is to solve an equation, we need to get down to a single x. And when you have an x squared term and an x term, there's no way to combine them. They're not like terms, and it makes it really challenging to do that until we learn some new tricks. So one of our tricks is if the equation is factorable, set it equal to 0, factor it, and you can split it into simpler equations. That is always the easiest method. That is always the best one. The problem is not everything is factorable. And I think that what we'll find is this one. Yep, I'm looking carefully now. This one would not have been factorable. If we subtracted that 5 to the other side, we would have gotten stuck. So I would always, given a choice, try factoring first. Your homework's going to ask you to complete the square so that you can get some practice. But one of our goals will be to, at the end of all this, once we've got our 3 different methods under our belt, look at these and try and be smart about choosing which one we want to use. Okay, so now that I'm down to a single x on one side of my variable, this should be a lot easier to solve. And that's what complete the square does for you. It gets you from an x squared and an x to a single x, and that's why it's powerful in multiple different situations. Even though it seems really tricky and tedious at first, if you can get this trick down, it'll start to feel like a really quick, easy way to get some good information. So I need to reverse order of operations. So I'm seeing that the first thing done is I subtract 3 halves, and the second thing done is I square, which means I'm only going to have to get rid of 2 things. I'm going to get rid of the square root. Remember that to get rid of a square, let me try that again. I need to get rid of the square first. To get rid of a square, you need to use a square root. And whenever you do that, introduce a square root, you need to include a plus or minus. So the question is, what do I square to get 29 over fourths? And the answer is there's two things, a positive thing and a negative thing. I did do a step in here, so let me just show it in case anyone doesn't like it. Really, I get the root of 29 over 4, which is the same as root 29 over root 4, which is where that 2 is coming from. So if you've got perfect squares, take advantage, take the square roots. Okay, so the only thing I have left to do is get rid of that 3/2, so I'm going to add that to both sides. Since it doesn't have the root, I can't combine it with the root 29. So you can write it, it doesn't matter if it's before or after this, we're adding it on. The reason I'm putting it before is because in the next section, we'll be using the quadratic formula, and the answers from that look like this. So I don't really care if you add those two fractions together, but I just want you kind of used to seeing these messy answers. So that's the solution. I got two answers, which happens a lot. We're used to that. You could also get none. You could also get one, but two we see a lot of. So that's how you use complete the square to help you solve an equation. It helps you get down from two of your variable with different powers to just one of your variable, which makes it easier to solve.